Hello guys, welcome to Self-Help Maths Academy. Today we are going to discuss about Lagrange's mean value theorem and we will understand the meaning of it and geometrical interpretation. So what is the Lagrange's mean value theorem? If a function f, if it is defined on the closed interval ab, then the first condition is if it is continuous on the closed interval AB, as we have seen in the last Rolle's theorem. Here also it should be continuous on the closed interval AB. It should be derivable on the open interval AB. Then there exists one real number C in the open interval AB such that this condition must satisfied. Okay, so it says that there is a function. It should be continuous in the closed interval AB. It should be derivable in the open interval AB. If these two conditions are satisfied, then we will have one real number in the open interval AB such that this condition is satisfied. So let us see geometrically what they are trying to say. So here basically, like, say, let me have this is a figure x-axis and y-axis. If you see this AB, a and b are the 2 points on the graph of a function y equal to f of x. Okay, y equal to f of x, corresponding to, you can see this a and b are in 2 points on the function y equal to f of x. Okay, corresponding to x equal to a. Here you see this is a point x equal to a and x equal to b here. And then you have got the coordinates a and b. If you see with respect to a, this point, let me write it here. This point will be your a comma f of a. The point b will be corresponding to b comma f of b respectively. Okay, so now when you want the slope of the chord ab, okay, this you know that by the slope intercept form, the slope the point form, if you use, that is simply y2 minus y1 upon x2 minus x1. So here if you see, your points are you have your a f comma a and b f comma b, like they act as your x1 y1 x2 y2. So therefore we'll be using this one. So y2 minus y1 is f of b minus f of a, and x2 minus x1 is b minus a. So therefore by using the new slope chord here, the slope of the chord, slope of AB, the chord AB will be simply f of b minus f of a upon b minus a. So by using our slope form, this form, okay, so we can write this one. Now since you know that your f, if you see this function, it is continuous on this interval from a to b. If you see this in a geometrical understanding, without picking up my pen I can draw this, right? So this is continuous in the closed interval AB. Okay, so here given interval this a, between a and b, if you observe this particular function here from here to here, this is continuous on the closed interval, that therefore f has no gap or a jump. If you see, there is no gap or a jump from a to b. Okay, also f is derivable on the open interval AB. Okay, if you see, this function is derivable in the open interval AB. Therefore, at every point between A and B, the curve has a unique tangent. Okay, so in between, for example, at any point, if you consider, there will be a unique tangent between A and B. Okay, the curve has a unique tangent. So it is evident from the figures that there is at least one point between A and B. Okay, the tangent at which it is parallel to the chord AB. So we will have the we will have that there is at least one point at between A and B, this A and B. So the tangent at which it is parallel to the chord AB. Okay, so if C is the, like, abscissa of P, like say for example this C is the abscissa of P, then the slope of the tangent of P, this will be like the slope of the tangent of this P at a point P will be your f dash of C. Okay, if I'm drawing this one, if you see this tangent at a point, let me take the color, the tangent, this tangent P, this tangent at a point P. Okay, so this particular thing will be your f dash of C. So therefore the chord AB, this chord AB is parallel to the tangent. If you see, this chord AB is parallel to the tangent P. Okay, if you see like this, This is parallel to this tangent P. Okay, so therefore we can write this as f dash of C is equal to f of B minus f of A upon B minus A. So that is actually the meaning, the geometrical interpretation with respect to this figure you have seen. So maybe like your function is like this. This is also continuous between A and B. Okay, here we have different tangents. If you see, this is different tangents we have at a point P1, at a point P2. So here this tangent is also parallel to the chord AB. This tangent is also parallel to the chord AB, and it is between A and B points. So here C is if with respect to this P1, if you see this one, this line, if you observe this line at this point C1, which lies between the interval, open interval AB. Similarly, if you consider this as your A, so there is a point C still belongs to the open interval AB. This part we are taking it as f of A. So this, like, the chord is A comma f of A. This point will be your B comma f of B. So the same understanding, I mean, like, just I'm trying to make you understand that whether you have got the function, maybe this type of curve, or it is a simple curve, until and unless it is continuous. Okay, it is continuous, and we have these two conditions which are satisfied, continuous in derivability in the closed and in the open interval respectively. Then we have a point C in between A and B, open interval AB, such that our this condition is satisfied. Okay, so that is the basic understanding. So now what we will do is we will straight go to the examples, and we try to verify this mean value theorem. Okay, let's see. We'll see the example now. Okay, let me take now the example that let us verify the mean value theorem for this function. Okay, so in the closed interval 0 comma 1 by 2. So here basically this function is a polynomial. Okay, so this function is polynomial. So what we have got, let me take this as, let f of x is equal to, we will write this as x into x minus 1 into x minus 2. So let us try to simplify this one. This is x minus 1 into x minus 2. Okay, so this we can write it as x into x times of x is x square minus 2x minus x plus 2. So let us multiply this till x square minus 3x plus 2. If I multiply this till, it is x cube minus 3x square plus 2x. Okay, so here this is our final polynomial. This is our function. Okay, so this is a polynomial of order 3. As we know, this being a polynomial in x, it is continuous in the closed interval. Okay, so the first condition is f of x being a polynomial, so it is very interesting when it is polynomial. So no, like, there is no much work, so you can directly tell that it's a continuous polynomial. It is continuous on the, sorry, it is continuous in the closed interval, 0 comma 1 by 2. Okay, that is how it is given. So now let us we have to check the second one, that is derivability. So here what will happen to the f dash of x? Your f of x is x cube minus 3x square plus 2x. So f dash x will be 3x square minus 6x plus 2, and f dash of x is always unique. Okay, and it is definite for every value of x, and it is definite for every value of x within the interval, open interval 0 comma 1 by 2. Okay, so hence the second condition, hence it is derivable in the open interval 0 comma 1 by 2. Okay, so therefore the f of x satisfies the two conditions of the mean value theorem, the first and the second conditions. So therefore from the theorem there should be a point, therefore there exists a point C within the interval 0 comma 1 by 2 such that your f of, if you see f of, here it is, this is your A and this is your B, f of B, f at the point of 1 by 2, f at the point of 0 upon 1 by 2 minus 0 should be equal to f dash of C. Okay, so this is what we have the condition, because your condition of the mean value theorem is what? It is f dash of C should be equal to f of B minus f of A upon B minus A, and in this case your A is 0 and B is 1 by 2. Okay, so like this we are modifying our function. Now f at the point of 1 by 2 means we have our function as what? Your function is f of x equal to, f of x is x cube minus 3x square, x cube minus 3x square plus 2x. This is our function. So this will be like f at the point of half, this will be like 1 by 2 cube minus 3 into 1 by 2 square plus 2 into 1 by 2. So this is simply 1 over 8 minus 1 by 4, and this is like 3 by 4, and this 2 cancels, it is simply 1 here. Okay, so this function, like let us do the LCM. The LCM is 8, so this will be 1 minus 3 plus 8 upon 8. So this is a 9 minus 3, which is equal to 6 over 8. So this is simply 3 over 4. So you have got your f of 1 by 2 is 3 over 4. And f of 0 will be, when I put 0 here, it is 0. Okay, so we have got the value. Now let us substitute that in this equation. Okay, so we will get this is equal to 3 by 4 minus 0 upon 1 by 2 minus 0 is 1 by 2, which is equal to f dash of C. Okay, f dash of C. This is what we have got now. But what is our f dash of C? What is our f dash of C? So we have already calculated our f dash of x. So this is our f dash of x. Put wherever x is there C, you will get the f dash of C. So clearly f dash of C is equal to 3c square minus 6c plus 2. Okay, so now let me write the value here, and also I will simplify this one. This is 3 over 4. Let me take 1 by 2 on the upper side, so it will become 2 over 1, which is equal to 3c square minus 6c plus 2. So this is now 6 over 4. Okay, 6 over 4 is equal to 3c square minus 6c plus 2. Okay, yes. Now this is equal to, now this is 2 times of 3, 2 times of 2. So this 2 I can multiply here this side. This is 3 into, this is 2 into 3c square minus 6c plus 2. Simplifying, 3 equal to 6c square minus 12c plus 4. Okay, or you can write this as 6c square minus 12c. I'll take this 3 on the other hand. It becomes plus 4 minus 3 equal to 0. 6c square minus 12c plus 1 equal to 0. So this is our equation now. Okay, now after multiplication I should get 6. After addition or subtraction I should get 12, which is a bit complicated. So let me use our usual methods. So here our A is 6, B is negative 12, and C is 1. So therefore let us find out our x by using this formula, minus b plus or minus square root of b square minus 4ac upon 2a. Okay, so let us substitute the values here. This will be minus of minus 12 plus or minus minus 12 the whole square minus 4 into 6 into 1 upon 2 times of 6. So this is equal to, this is 12 here, plus or minus, this is 144 minus 24 upon 12. So this is again 12 plus or minus, this will be 120 upon 12. Okay, so I think now we are this we can write it as plus or minus. This is like let me do, you can do with a calculator. What is our square root of 120? Square root of 120 we want. Let me write it. Yeah, this will be like we get 10.95 upon 12. Okay, so here you will be getting one value as 12 plus 10.95 upon 12, or you will be getting 12 minus 10.95 upon 12. Okay, so these are the two values you are getting. So let me see what are the answers we are getting. This is 32.95 divided by 12, which is this is 2.74, or this is another one is okay 22.95 divided by 12. Sorry, this is not this value, this is 22, right? So we'll get here 1.91, and this one is let me calculate this one. So this is 2 point, let me 12 divided by 12, so this is point or 0.0875. okay, so here we have got two values. I think of these two, out of these two, 0 between 0 and half, that is 0 and half is 0 and 0.5. So between this is the value, the second value actually lies, right? So therefore we can take the second value. There is a point, this one, the second value, this point, the second value, this one, lies in between the open interval 0 and 1 by 2. Hence we can say, conclude, hence there exists at least one value C which is equal to 0.0875. Okay, that we can write within the open interval 0 and half, such that f of half minus f of 0 upon half minus 0 is equal to f dash of c. This is the condition. Okay, so this means what? Hence the verification of the mean value theorem. Hence the verification of the mean value theorem. In short, we also call it as MVT, mean value theorem. Okay, so this is one example how we go for this particular type of example. Okay, so now let me take another example. Here they have given us f of x equal to, say, x square minus 3x plus 2. It is in the interval, closed interval, minus 2 to 3. Okay, so again, as if you see the given function, it is a polynomial of order 2. So here f of x is equal to x cube minus 3x plus 2. Yeah, it is a polynomial in x, and basically it's a polynomial of order 2. So hence it is continuous for every value of x. So it has to be continuous in the closed interval -2 to 3. Okay, so we can write it here, f of x being a polynomial in x is continuous for every value of x. Okay, so it is also continuous in the closed interval -2 to 3. That is our first condition. The second condition is the derivability. Okay, so also if you check again, you can check your f dash of x. F dash of x is what? 2x minus 3. So this 2x minus 3, it is finite and unique. For every value in the open interval, or unique in the open interval -2, 3. Okay, so therefore what? F of x is derivable. You can say f of x is derivable. It is derivable in the open interval -2, 3. Okay, so thus f of x satisfies both the condition of your MVT, I mean the mean value theorem. F of x satisfies both the conditions of MVT, mean value theorem. Okay, so therefore by the mean value theorem there exists C belongs to the open interval -2 to 3, such that what? Such that our condition is f of b minus f of a upon b minus a must be equal to f dash of c. In this case, our a is -2. I'll just write it for your reference. Here, our a is -2 and b is 3. So therefore, it should look like f of 3 minus f of -2 divided by 3 minus of -2. Okay, this should be equal to f dash of c. Okay, so what is our f of 3? Now we have our function f of x as this is our function x square minus 3x plus 2, x square minus x square minus 3x plus 2. This is our function x square. Yes, so our f of 3 will be equal to, put wherever x is there, 3. This will be 3 into 3 plus 2, 9 minus 9 plus 2, which is equal to 2. Similarly, f at the point of -2 we want. So it is -2 square, 3 into -2 plus 2. So this is 4 plus 6 plus 2, which is equal to 12. Now substituting these values, we get here 2. F of 3 is 2 and minus this is 12 upon 3 plus minus of minus, that is equal to 5, which is equal to f dash of c. Let me also take out our f dash of x. Our f dash of x is 2x minus 3. So therefore our f dash of c will be, wherever x is there, put c. So it is 2c minus 3. Let me write that here. Okay, this will be equal to 2c minus 3. So this will be minus 10 over 5, which is equal to 2c minus 3. Let me take the 5 on the other hand. It becomes minus 10 equal to 5 times of 2c minus 3. Okay, so this is minus 10 equal to 10c minus 15. So take all the terms, now we will take the numbers on the other hand. This will be 10c equal to minus 10. This 15 on the other hand, it will become plus 15. So 10c equal to 5 implies dividing both the side with 10. So c will be equal to 1 over 2, or you can write this as 0.5. Okay, yeah. So our interval, the given interval is -2 and 3. If you see, the given interval is -2. Say if you just write this as -1, 0, 1, 2, say 3. Your given interval is this one. Okay, so given interval is -2 and 3. Your 0.5 is somewhere here. So 0.5. So if you see, this 0.5 lies within the open interval -2 comma 3 in such a way that we can say that we got clearly our c belongs to the open interval -2 comma 3, such that f of 3 minus f of -2 upon 3 minus of -2 is equal to, we have got f dash of c. Okay, so this is the condition, it's satisfied. So therefore the mean value theorem is verified. Okay, you can write hence the MVT, mean value theorem, is verified. Okay, verified. So let me give you one example for you to just check whether it is verifying the mean value theorem, or the Lagrange's mean value theorem will be applied or not. So let me give you, so you can just use them as your practice questions. Like f of x equal to, you have 2x square minus 10x plus 29 on the closed interval, say 2 comma 7. So this is one, and another one, let me give you f of x equal to x cube plus x square minus 6x This is on the closed interval minus 1 to 4. Okay, these are simple examples, guys. So just verify the mean value theorem for these functions, whether they satisfy the mean value theorem or not, and comment your answers in the box. So share with your other friends for their benefit in your students community, and get back to me if you have any questions, any queries. I think in the next video we will talk about some other concept. Okay, I think until then, take care, guys. See you all in the next video. Bye bye.